Measuring voice onset time. You may remember our discussion on VOT during our coursework. We explored that there are three possibilities for VOT, right? One is the negative VOT, then the second is zero VOT, and the third one is positive VOT. It's a feature of stop sounds, and particularly it's correlated with the aspirated sounds, right? Because it's a positive within aspirated sounds, aspirated stops. And then the length of VOT is also important in order to just explore stops across languages and even stops in terms of their place of articulations. Okay, so we are going to learn now how to measure VOT within stops. All right, so we would record, and then after recording we would zoom in through our stop sounds, and we would explore and analyze the patterns of stops by showing you the negative, zero, and positive VOT, and then we would also tell you that how they are correlated with voice sounds, voiceless unaspirated, and then voiceless aspirated sounds, right? So that would be done, and we would let you know the very easy way to calculate VOT. So let's go to recording and then exploring through Prath. Okay, guys, so we are going to record for measuring VOT, and we would record this in shapes like sounds, okay, starting with a voice sound, ba, then with voiceless pa, and then with voiceless aspirated pa, okay, and you would see the differences then. All right, so I'm recording it again, the mono sound, and through the recording window, I'm recording it now. Ba, pa, pa. Right, so I'm saving to list now. All right, minimizing this, and now viewing and editing it through the Prath window. Okay, so this is basically the ba sound by zooming in now. This is zooming in, and you can see that how is this voicing started even before the release. Okay, the bar is there and it is there, right? So this is called negative VOT. If I just play this for you, ba, 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 ba. Okay, so this is there, and in technical terminology, this is called negative VOT because the voicing has already started before the start of the voicing of the vowel. Okay, so it's the starting of the voicing before the starting of the voicing for the vowel. Okay, the following vowel. Now let me take you to one more example, which is unaspirated pa, 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 pa. And in this case, you can see just by zooming in that the moment the pa is released, okay, then just after the release, this is release basically, if you can just see here, okay, so after the release, this voicing is starting, right? So the voicing is starting with pa, 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 with the vowel, okay, with the vowel, you see, pa, pa, right. And now if I just take you to the aspirated pa, then we would see the difference. Pa, 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 pa. All right. So just by zooming in and taking you to this part, right? So you see it here that this part is basically the aspiration, and it is the aspiration which is visible, and then the voicing is delayed for this part. The voicing of the vowel, the vowel onset is it is delayed, and it is delayed for this length of time, and this is the positive VOT, right? This part is the positive VOT. If I just zoom in a little more, it is 0.29. So it's like almost the 30 millisecond, and that's the VOT for the aspirated per sound. Okay, it is even a little bit more than that. So this was the positive VOT, and for the per sound, the unaspirated voiceless, it was 0, and for the voiced burr, it was negative, right? Because the voicing then starts in the case of burr before the onset of the vowel, right? So in that case, it was a negative, okay? And in the case of per, unaspirated voiceless sound, it starts the moment the release is, occur, and then the vowel starts. So in the case of per, unaspirated voiceless, it was 0. And then in the case of per, aspirated per, it was a positive, right? So that's the difference between the three categories of stops and the VOT measurement for them.